Hi, good morning, my dears. Today we are going to learn about acoustics. Acoustics mainly study about sounds. Acoustic is a branch of physics that deal with the production of sound, transmission of sound, reception of different sounds, control and effect of sounds. In this lesson, we are going to discuss about how sound is produced, how that sound is propagated, how can we hear sounds. Different sounds hear our daily life. When a lion roars, when we play the musical instruments, water pouring a glass tumbler, bat hitting the ball, and water hit the rocks are the sounds we can hear our surroundings. What's the use of sound? Sound mainly help us to communicate with each other. What produces the sound? The sound is produced by vibration. What is vibration? Vibrations are to or fro motions. For example, when you are taking the rubber band, just strike out the rubber band move to or fro motions. So these motion only called vibrations. Vibrations only produce the sound. Sound requires medium for propagation, which means sound need a medium to travel from one place to another. How does sound travel to the medium? What happens to the particle? Already we know that sound is produced by vibrations. This set of particles to vibrate. The vibrations pass to the adjacent particles. This process continues in the medium till the sound reaches our ear. This is the way sound travels through the medium. Particles are not traveling from source to our ear, but disturbance producing the source, which is in the medium. This disturbance create the vibrations in the medium is called sound wave. Let us discuss with one example. Now take the tuning fork. Now air in the medium. Now the tuning fork is rest, not vibrating. We cannot hear any sound. Now take the rubber pad. Touch with the tuning fork with the rubber pad. We cannot hear the sound. The tuning fork is strike with the rubber pad. We can hear the sound, which means the tuning fork is vibrating. Some of the regions are high density called compressions. Some of the regions are low density called rarefactions. These series of compressions and rarefactions to form the sound wave called longitudinal wave. Let us discuss with one more example how longitudinal waves are formed. Take the coil or spring, hold your hand in this manner. Push or pull in the spring, some parts of the coil are come closer. Some parts of the coil are moved far away. The particle of medium vibrate along the direction of propagation or parallel to the direction of propagations called longitudinal wave. Example, sound wave. Then the coil is moved up and downward more direction. The particle of medium vibrate perpendicular to the directions. This is called the transverse wave. Example, light wave. Can sound wave travel through vacuum? No, sound wave cannot travel through vacuum. Suppose we are in the moon means we cannot hear any sound because the moon does not have any air medium. Categories of sound waves based on their frequencies, audible sounds and non-audible sounds. We know that sound is produced by a vibrating body. Vibration means to and fro motion of an object called vibration. The frequency is expressed in hertz, with its symbol is Hz. 1 hertz equal to 1 oscillation or 1 vibrations per second. The number of vibrations per second is called frequency. The sound frequency is less than 20 vibrations per second at 20 Hz cannot hear by human ear. This is called inaudible sounds. Similarly, the sound of frequency higher than 20 vibrations per second or 20 kHz also inaudible for human. Hence, the human range is 20 Hz to 20,000 Hz only we can hear. So, this is called audible sound waves. The sound of frequency is higher than 20,000 vibrations per second or 20 kHz are called ultrasonic sound waves. The sound waves of frequencies less than 20 vibrations or 20 Hz are called infrasonic sound waves. Difference between the sound wave and light wave. Sound wave. Sound waves need a material medium for their propagations. Sound wave only travel in air or water or solid-like substance only. Light waves do not need any material medium for their propagations. They travel even through in vacuum. They does not require any medium for travel. Sound waves are longitudinal. The particle of medium vibrate along the direction of propagations. Light waves are transverse. The particle of medium vibrate perpendicular to the directions. Sound waves have very low speed at 330 to 350 meter by second in room temperature. Light waves speed in 3 into 10 power 8 meter by second in vacuum or air. The wavelength of sound wave in 1.65 centimeter to 1.65 meter. The wavelength of range from light wave is 4 into 10 power meter to 7 into 10 power 7 meter.